Hi. Uh, Very often in Houdini we need setups where points or objects move along curves. To make this easy, I've built an HDA that covers almost everything you'd want to animating points along curves. With this tool you can control how many points you have, the speed and variations, the direction they move, the style of motion, and even how they slow down, including slowing down only part of the points. Um, you also get full control over how they orient cells along the curve. You can also pick from several visualization methods and later use them for rendering. Each parameter has a short explanation, so it's easy to follow along. Let's take a look at how this works. I've set up a few test examples in a scene to show the workflow in action. To make visualization clearer, I've placed box object on the points. I already have some basic setting applied, but let's play around with them and see how the changes affect the result. Okay, main parameters: point count, base speed, and variation. Now we have only 1 point moving on a curve. Base speed you can change. All parameters you can change real time. Now, because variation type is the same speed, it doesn't work. We need to change to random. And now every point has a random speed. Um, Time offset. For time offset, you need to add some points to the curve. One is not enough. I decrease the speed. You see now is every curve has 3 points, and you can change the time offset between them. A normalized speed. If you turn on speed normalization, all curves will finish the animation in the same time, in the same amount of time, no matter the length. With this enabled, the speed automatically adjusts based on curve length, using the reference value as the baseline. Let's change the curve length. Okay. You see, normalized speed now is off. All points are moving in the same speed. If we turn it on, the length of the curve has influence on the speed. This is really handy when you want to synchronize motion across multiple curves. If you leave it off, the motion feels more natural. Longer curves takes more time to traverse. To see the length of the curve, you can also enable debugging info to check the actual curve length. See here is a maximum is a 4. You can enter this parameter here. Variation types. Let's set back to their normal length. Variation types. There is a few speed options you can choose from. Same speed. Sorry. Now points moving same speed. Random variation, but for random variation you need to change the speed variation. And the third one is by attributes. The attributes, you can set attributes speed variation, you can assign the attributes to the curve points. That attributes work as a multiplier for base speed. And here I just contrast it a little bit. Now you can see part of the points moving faster and part of them slow. Loop motion. Here you decide how the points will move without looping or with looping or in ping-pong style. The difference is easy to see if you run a point along the circle. I have a different setup for a circle running. Okay. Now you can see we had one point moving every circle, and we turn on the loop motion. With loop turn it on, once the point finishes the circle, it immediately starts over again, giving us continuous motion. If we change it for no looping, the points is stop. But if we change it to ping pong, the point is change direction. Oops. Yeah. let's back to our ring. Okay, direction mode. There are several direction options you can use. Only forward, backward, ping pong, mix. Mix gives a random combination of forward and backward motion. And radial direction alternates between curves. One goes forward and next go backward. Forward. Ping pong. Okay. Ease mode. Now it's linear. Next you can choose the motion character. Linear gives you uniform motion. This is especially useful for points are moving along a circle. Or you can use ease in presets. Ease in, ease out, or slow down, speed up, or both. Distribution mode are here's where you control how points are instantly spread along the curve. With uniform, the points are spaced evenly at regular intervals. Random scatter them in a more chaotic way. And cluster where points group near the center, and you can adjust how tightly they cluster using the cluster amount parameter. A start mode it's about timing. Now let's talk about timing. Here you control how the animation starts by setting the delay pattern. With no delay, all points move in at the same time. You can choose the progressive. There's a cascading effect. Each curve starts one after another, step by step, and with random delay, every point gets its own individual delay, so the motion feels more scattered and unpredictable. Let's decrease it a little bit. Okay, next up is the orientation. We can just check it with another setup, spirals. Orientation. In this section, you decide whatever of the points should align the orientation of the curve. Then it's enabled. Each point will rotate to follow the curve's direction. These options calculate orientation vectors for points. Then it's off. The points only have position data, no orientation. Then it's on. Each point gets a full 3D coordinate frame, including the normal, the up vector, and tangent. For these options to work, you need to place polyframe node before HDA to specify the normal and tangent. Orientation methods. The orientation you got 3 algorithms to choose from. Normal plus up vector. This is simplest and fastest, but sometimes the orientation can flip. In this particular case, is working okay. Quaternion gives a more stable result using quaternion math. And parallel transport is the smoothest with no twisting, though it's more computationally expensive. Then you enable geometry normals. You are using information provided by a polyframe node. It's best to leave this option on for greater accuracy. The disabling this might be useful if you want to manually enter the up vector. Let's check it here. For example, orientation. This can be handy for curved line on the same plane. It works with orientation mode use geometry normal off, and orientation mode 0, normals and up, and you can an additional option then appear to set up the up vector manually. You can see you can now change up vector. twist amount. In all three orientation modes, you can also control the rotation angle. This lets you adjust the angle around the curve tangent as the point moves forward. The result is a spiral-like twisting motion added to the orientation along a curve. A twist ramp. With twist ramp, you can remap the twist along the curve for even more precise control. Okay. Trail. These options lets you generate trail points that follow the main animated points. The effect looks like ghosting or motion blur with delayed copies trailing behind. The setup is simple. You adjust the trail length, the offset and scale. You can switch over trail, fade off. And if needed, you can even connect those trail points with a curve. You can see now it's only points, and you can grid trail curve on. Now you have the curves. Color mode, visualize. For coloring the animated points, you have got a few simple modes to choose from. By line, just make it more interesting. Really. By line gives each curve by line gives each curve its own color, almost like a rainbow effect. Custom ramp. Lets you to set the color manually using ramp. And random float, assign each curve a random value between 0 and 1, which you can later use in rendering. And with a random clamp, you can limit that random value to a specific range to make it more lighter or darker. Performance tab. Remove stationary points. You can remove stationary points for optimization. This helps keep things running smoothly when you have a lot of curves. Now you see stationary points, and you can remove it. The reference length. The reference length is used for speed normalization. Points of curves that match this length will move exactly at the base speed. Shorter curves will move faster, while longer curves will move down proportionally. If you want to check the actual curve length, I told you before, just enable the debug options. It will display all the necessary data. Now you can see the length of the curve, count the points, everything you need. The attributes in the attributes section, you will find a list of the attributes with HDR outputs. This gives you a clear overview of the data available for points and curves. So you know exactly what you can use later in your workflow. Each parameters already has a detailed explanation writing for it. You can find all these descriptions collected at the bottom of a section inside the info area. I think I cover everything. This HDA is a flexible and powerful tool for animating points along the curves. You get full control over motion, orientation, and visualization. All the parameters are organized, and each one comes with a detailed description, making the setup clear and easy to use. Thank you for listening.